Okay, so this is module 6 of part 8. So for this module, we will be discussing nuclear magnetic resonance spectroscopy. Now, we will focus more on the instrumentation and some of the basic theories on of NMR. Yung interpretation, konti lang, no? We'll just review some concepts, no, of NMR spectra interpretation. But then the more detailed explanation will be given in organic chem, or was given already, no, in organic chemistry. So NMR spectroscopy is actually used to determine the relative location of atoms within a molecule. So if you're familiar with NMR from organic chemistry, di ba yung proton NMR or yung carbon-13 NMR, basically what you are detecting for each of the peaks or signal in your spectra are the nature of the neighboring atoms. Alright? So, yung relative location of particular atom within the chemical environment ng molecule. Okay? So, for carbon-13 NMR, familiar tayo. Proton NMR, we're familiar with that. Basically, it maps out the framework of your molecule. Okay? So, it is usually used in tandem with other spectroscopic techniques such as mass spectrometry and FTIR spectroscopy and even UV-Vis spectroscopy. But, even with just the NMR and the molecular weight information, you would be able to deduce the structure of a simple organic molecule. Okay? So, NMR, as the name implies, so magnetic resonance, depends on the use of very strong magnetic fields. No? Yung concept ng NMR is quite similar to your MRI, no? Magnetic resonance imaging. Okay, so medyo similar sila. Hindi lang limited ang NMR for carbon-13 and proton NMR, no? But it can actually be used for any element, isotope, no? Any nuclei containing odd number of protons or neutrons. So, other examples of nuclei being NMR active, no? So you have your nitrogen, no? Nitrogen 14, fluorine 19, and your phosphorus 31. Alright, no? So for any nuclei, no, each nuclei actually spins along its axis, okay? And it has its own internal magnetic field, no, because of this spinning action. Now for the proton and carbon-13, no, yung mga special na sinabi nating nuclei, if you subject these nuclei against an external magnetic field, then their corresponding internal magnetic fields will align parallel or against that particular external magnetic field. So makikita natin dito, without the external magnetic field, they are randomly oriented, but once you turn on the external magnetic field, they align, no, either parallel or against this external magnetic field. Now, the parallel orientation, alright, of each the spin of the nuclei is the most populated one, and hence ito yung pinaka-ground state natin, no? But once you can actually promote, alright, the energy level of this nuclei by irradiating your sample or nuclei with electromagnetic radiation, no? So you would be able to induce what you call rotational transition, so they will be promoted to a higher energy level. And to do that, instead of using UV-Vis and IR, those type of radiation are very strong. So we want to use electromagnetic radiation whose energy is not so strong as to induce electronic and vibrational transition. So we want rotational transition only. So for NMR, what we are using is radio frequencies or radio waves. Alright, so similar to what we discussed in UV spectroscopy or infrared spectroscopy, here the energy of the radio wave or the radio frequency, okay, should be equal to the energy difference, no, between the two energy levels, no. So sabi nga to flip, all right, the spin of the nuclei into anti-parallel state. Okay, no, so we should be able to feed or to irradiate the nuclei with this energy difference, no, between the two. Okay, now the energy needed for to induce this flipping, no, into a anti-parallel state is actually related to the molecular environment and is proportional to the magnetic field strength. No, so this is the reason why the amount of radio wave energy, no, needed to induce a rotational transition for a particular nuclei depends on its chemical environment, no. Ibig sabihin nito, ano yung mga kapitbahay niyang atoms, no. So from here, no, dito niyo nakukuha yung term na shielded and deshielded, no, yung downfield and upfield na terms. So we will show that in the next slide. Alright, so shown here are the proton and carbon-13 NMR for this ester. Alright, methyl, ano ba to? Methyl ethanoate. Alright, yan. Or methyl acetate. Ito rin pala. Alright, so ito yung proton NMR. Ito yung carbon-13 NMR. Now, we are looking at, in NMR, we are looking at the nuclei, no? So, in the case of proton NMR, we are looking at the protons, no? Yung H1. And for carbon-13 NMR, we are looking at the carbon nuclei, okay? Now, since the nuclei, no, the proton and carbon nuclei are bonded in the molecule, each bond contains electrons, alright? And these electrons in the bonds actually shields your nuclei, your proton and your carbon nuclei from the effects of the magnetic field. So when they are shielded, it is more difficult, alright, for your nuclei to be affected by radio frequencies, no? Radio frequencies and hence, no, yung magnetic field din. Alright. So, because it's dependent, no, this particular shielding effect is dependent on your on the electrons, no, in the chemical bond, different signals appear for nuclei in different environments, no? So, tingnan natin muna ito, no, yung proton NMR, okay, for methyl acetate or methyl ethanoate. As we can see, each of the protons here, no, H3, are located or attached in your methyl groups. So, parehong methyl group. But as we can see here, the signal for the methyl protons, no, methyl protons dun sa nakakabit sa oxygen is more towards the left, no? More downfield compared to your methyl protons connected to your carbonyl group. Okay? So, bakit ganito yung nature, no? It has something to do with the electronegativity, alright, of the neighboring atoms, no? Connected doon sa molecular bond. Okay? The higher the molecular, the electronegativity of the neighboring atoms, the more shielded yung nuclei of interest. Bakit? Because you are pulling away, no? The neighboring atoms are pulling away these electrons that are supposed to shield the nuclei of interest. Alright? So this the shielding, okay, makes your nuclei more susceptible to the effects of the magnetic field and hence the radio waves. Okay? So here, in the case of methyl ethanoate, okay, yung metal na ito is more upfield, no? So bakit more upfield yan? Because the carbonyl, carbon, is, well, it is it tends to pull away, no? Yung carbonyl group pala, no? It tends to pull away the electrons, okay? But not as strong as oxygen atom itself. Okay? We expect that oxygen bonded to this carbon will have a stronger pulling power compared to your carbonyl functional group. Okay? So since mas shielded itong protons dito, mas downfield yung signal niya. The same is true with carbon-13 NMR. So for carbon-13 NMR, so as we can see here, well, dito pala muna, you have two signals because you have two different proton environments. Alright? Or basically two different protons in general. Whereas for the carbon-13 NMR, we have three, okay, different carbon environment. So, isang information yan na natin tignan. So, kung makikita natin dito, sorry for the color, mix up. Okay? So, this carbon here, the one attached to your carbonyl is this one, at around 20 ppm. This carbon here is around, say, 50, no? Mga 50-55 ppm. And the carbonyl carbon is much downfield, no? Down to around 170 ppm. Okay, and again, this has something to do with electronegativity. Okay, the carbonyl carbon is the most downfield, has the most downfield signal because it's doubly bonded to an oxygen, no? And may isa pang oxygen dito, no? So this makes the nuclei more deshielded, okay, and hence more susceptible to our magnetic field, no? This metal here is around 55 ppm, again because it's attached to an electronegative oxygen, whereas this one, since lesser yung electronegativity ng carbonyl group, to influence the electrons, no, in this particular bond, no, it's located at a more upfield location in the NMR spectra. Okay, so this is a simplified version of the NMR spectrometer. So as you can see here, no, the sample is actually placed on a long, thin tube, usually made from, I think, glass or quartz, no? And then you dissolve the sample in a solvent that does not have a signal itself, okay, or whose signal is far away from the signal of your analyte. So in most cases, what they use are deuterated solvents, no, such as deuterated dichloromethane or deuterated chloroform. So when you say deuterated, the hydrogens are replaced with deuterium, okay, yung H2. Alright, so here the tube is placed between the gap, no, within the gap of a magnet. Alright, so you spin around the wire, no, okay, to make it to make it surrounded by the magnet, no. So ito yung magi-induce ng magnetic field. Alright, so you have a radio frequency generator here. So basically absorption spectroscopy lang din ito, no. So the radio frequency energy is transmitted, okay, across the sample under the wherein the sample is under the influence of an external magnetic field, and you have a detector and amplifier here which measures the transmitted radio frequency, no? And then the signal processor will interpret it as absorption. So similar lang din, no? Absorption spectroscopy lang din. Okay? So for species that tend to interconvert, okay, the NMR spectrometer will give an average signal, no? And then post-analysis of this signal can be analyzed to find the rate of conversion. Alright, so yung mga transition states, no, sa organic chemistry, we can actually analyze, no, yung mga species na interconvert, no? Kunwari, yung mga tautomerism na tinatawag, no? Enol keto tautomerism. Alright, so nagkakaroon ng interconversion doon, di ba? So we can actually analyze that, no? Using your NMR spectroscopy. Okay, so what are the basic information that we can obtain from your NMR spectra? So first, you have the number of signals, no? So whether proton NMR or carbon-13 NMR, the number of signals will tell you the number of different types of that particular nuclei. So in the case of a proton NMR, the number of signals will tell you about the number of the different types of protons, no, or the different types of proton environments. Okay, so importante iyon, no? So if you have, say, for example, ito, no? So you have two signals. Oh, sorry, this is for carbon-13, no? Anyway, so for carbon-13, no, you have three signals. Okay, so bakit tatlo? Because you have three different carbons, no, or three different chemical environments for a carbon nuclei. Okay, so sa proton NMR, ganun lang din yung interpretation. Next is the chemical shifts, no? So the chemical shifts refers dun sa value nung o saan tumapat yung peaks nyo doon sa x-axis, yung ppm, no? Usually this is denoted by Greek letter delta. Ayan, small letter delta. Okay, so the value for the chemical shifts, no, of a particular peak will tell you about the type of the environment, no, for that particular nuclei, no, either proton or yung carbon-13 signal. Okay, so dito makikita whether shielded or deshielded yung particular nuclei na yun exhibiting that signal, no, sa NMR. So again, the more deshielded the nuclei is because of the influence of electronegative neighboring atoms, the more downfield the signal will be. So, mas more sa kaliwa, no, ng NMR spectra. Well, sa proton NMR, there's another special data that can be obtained, and it's what you refer to as the integration, no? So, kung maaalala, ito yung mga lumalabas sa parang pa-S-curve, no, sa ibabaw ng peaks. So, the length of this S-curve is associated with the proton ratio, alright, for that particular signal, and it will give you an idea what type of hydrogen, no, sa organic molecule naman. So if proton NMR, what type of hydrogen do you have, no? Do you have a CH3 type of hydrogen, so methyl group ba yan? Is it a methylene group, so CH2, okay, CH2, or is it a methylene group, no, so yung CH, alright? Or if you don't have an integration sa proton NMR, then that would suggest, ay, hindi pala lalabas yun dun, no, kasi nga we are only talking about the proton. So the integration gives you, kasi usually ba yung signal sa proton NMR talks about the nature of the neighbors, no, yung neighboring atoms. But the integration tells you information about the proton itself. Okay? So kung methyl, methylene, or methylene na yung signal mo. Okay? Then also the ratios of the number of protons. Again, this is something that you can get from the integration. Okay, the signal shape, no? Well, usually we are used to these sharp peaks, no, sa NMRs, no, proton NMR, carbon-13 NMR. But sa proton NMR, there are times that you can observe something that is broad, alright, broad shaped yung peaks, no? And usually this is associated with the dynamics of the proton environment. Okay, so normally yung broad peak na ito sa proton NMR, no? Sorry, this is carbon-13 NMR. So the broad peak in proton NMR is usually associated with what you call your D2O exchange. Okay, yung D2O exchange, no? So this usually happens if you have hydroxyl functionalities. Okay, signal splitting, no? So this is in proton NMRs, no? So signal splitting refers doon sa doublet, quartet, triplet type of signal, no? So instead of just seeing a signal peak, no, if you have a doublet, so it looks something like, hindi ko siya madraw yung tama. Yan, no? So you have a doublet, no? If you have a triplet, so you have a triplet. Okay? So if you remember from your organic chemistry, this follows your N plus 1 rule, no? Wherein this talks about the number of neighboring protons, no? So the signal splitting gives you information regarding the number and geometry of nearby protons. So these are the basic information that we get from our NMR spectra. Okay, so a little bit something about chemical shifts. Okay, so for chemical shifts, it is the unit is in ppm, parts per million. Okay, so saan ang galing ito, no? Bakit ppm ang chemical shifts, no? So the standard, okay, the zero baseline standard used in NMR is your trimethyl silane. Okay, so this is used as the standard for NMR chemical shifts, no? And we can see this in your NMR spectra. It has a it's denoted by 0 ppm, no? Or yung value ng chemical shift for trimethyl silane is set as 0 ppm. So in many NMR solvents, about 1% TMS is added, no? And this serves as your internal standard. Alright? So how does the system, the spectrometer, compute for the chemical shift, no? For the small delta? So basically, this is the equation. Ito madalas na lumalabas sa board exam, no? So please take note of this. So what we actually measure, alright, in NMR is the observed shift, okay, of your analyte signal from the trimethyl silane signal. Alright, and this is measured in hertz, okay, in terms of frequency. So rather than using wave number or wavelengths, okay, what we use here is yung frequency. So the chemical shift delta is computed as the observed shift of a particular signal ng analyte, no, from the TMS signal in hertz divided by the operating frequency of the instrument, also in hertz. So if you've seen an NMR spectrometer, no, it's usually rated in terms of its megahertz or gigahertz na gigahertz ba? Megahertz signal, no? For example, you have your 200 megahertz or 400 megahertz. So the higher the operating frequency of your NMR spectrometer, mas mahal because it will offer you much better resolution. Alright, so sa instrumentation, no, in NMR spectroscopy, when you say resolution, this is a measure of the degree by which an instrument can differentiate between two adjacent signals. So the better that you can separate two adjacent signals from each other, or discriminate, no, two adjacent signals from each other, we say that the instrument has a better resolution. Alright, so example of computing, no, for the chemical shift, no. So for example, for benzene, no, using a 300 megahertz instrument. So a particular signal for benzene, okay, was found to be 2181 hertz away, alright, away from the signal of your trimethyl-silane. Okay? So 2181 Hz divided by, so the rated frequency, operating frequency of your instrument is 300 megahertz. So in terms of hertz, that is equal to 300 times 10 to the 6th hertz. So you divide the two, then multiply it by a factor of 1 million. No? Kaya ppm yung unit. So you get 7.27 ppm. So that's it for Module 6 of Part 8. So again, I'll be posting the self-assessment exams in our FB group page.